Okay, so I want to continue talking about solving systems of equations. And in particular, this section is using a technique called solving by substitution. So solving by substitution. So solving a system of two linear equations and two variables by substitution. Oh, I spelled that wrong. Hold on. Tuition. Okay. Okay, so let me give you the rules on how to do this. We will do a bunch of examples. Then I will show you another technique, which is called elimination. Some people call it the addition method. That'll be in 4.3. And then after that, we will actually solve some applications, some word problems involving systems of equations. So I want to describe these two techniques first, substitution and elimination, and then I'll do the applications later. Okay, so to solve by substitution, there's several steps. So step one is in one of the equations, I want to solve for one of the variables. So it can either be for variable x or variable y, whatever one is easier to solve for. So in one of the equations, solve for one of the variables. Okay, then step two, and here's where the substitution comes in. Now substitute this expression from step one into the other equation. And then once you've done that, you can solve for the one remaining variable. So once you substitute this expression in, you're going to have just one equation in terms of one variable, and you can solve for that variable. So I'll say solve for the remaining variable, the one remaining variable. Okay, and then the third step is now you substitute the value found in step two in either of the original equations and solve for the other variable. So you can substitute the value. Now that we found x or y, whatever it is, we have a value for one of the variables. You plug that back into either of the original equations and you solve for the other variable. So substitute the value found in step two into either of the original equations and solve for the other variable. And again, this will make a lot more sense when we start looking at examples. I just want to make sure you have all the rules. Okay, so here's the first example. Let's say I want to solve this system by substitution. So I'll say solve by substitution. And here's my system. X minus y is equal to 15. And then say y equals negative 4x. Okay, so if you look at this system of two equations, the first step, if we want to use substitution, the first step is already done, right? Because if you look at the second equation here, I've already isolated the y. So I'll say step 1 is already done, right? Because I've isolated the y by itself. I've gotten the y by itself. So now step 2 is to take that expression and plug it in to the first equation, the other equation, the first equation, where I have a y. So where I have a y here, I'm going to plug in negative 4x. Right? So the first equation becomes now x minus, you got to be careful, you're plugging in a negative 4x equals 15. Okay, so that's where the substitution comes in. Now notice this equation is just in terms of x, so I can solve it for x, right? So we can combine like terms. What's x minus a negative 4x? Well, that's the same as x plus 4x. But that's just equal to 5x, right, is equal to 15. And if I divide by 5, I'm going to get x is equal to 3. Okay, so I'm half done, right? I have my x. Now I have to go back and find the y. Well, now I do step 3, which says I can take that x equals 3 and plug it into either equation. It doesn't matter which one. They will both give me the correct answer. But the easier equation to plug into is the second one because it's already written as y equals something. So I'm going to plug, I'll write it here, plug. So this is step 2. Step 1 is done. This was step 2 where I substituted in. And then step 3 was plug x equal 3 into either equation and solve for the remaining variable, which in this case is y. So it's going to be much easier to use the second one, right? Because the second one says y equals negative 4x. So now I can plug in, where I have an x, I'll plug in my 3 now. And if I worked it out, well, what's negative 4 times positive 3? That's negative 12. So I get y is equal to negative 12. So that's my solution. X equals 3, y equals negative 12. If I want to write it as a point, right, an ordered pair, in other words, if I want to write it as the point that these two lines pass through, like that, the point that lies on both lines, so it's the point at which the lines cross at, then it's going to be the point 3 comma negative 12. Remember, it's always written x, y. Okay, here's another example. Let's say I want to solve this system. So I have 3x plus 5y is equal to negative 1. Then I have 3x plus y is equal to negative 5. And I want to solve it using substitution. Okay? So remember, step 1 was to solve for one of the variables in one of the equations, right? So step 1, solve for one of the variables in one of the equations. Well, if you look at that, it looks like the easiest variable to solve for is maybe y in the second equation, right? Because I already have one y. I don't have to divide by anything at the end. So I'm going to take that second equation, 3x plus y is equal to negative 5, and I'm going to solve that for y. So how do I solve it for y? I need to isolate the y, so I need to subtract 3x. So I'm going to get y is equal to negative 3x minus 5. Okay, so I solve for one of the equations for one of the variables. Good, step 1 is done. Now step 2 was I take that expression, right, because y is now negative 3x minus 5, and I go to the other equation, and wherever I have a y, I'm going to plug in that expression. So I have 3x plus 5 times y, but y I can plug in now, negative 3x minus 5. That's equal to negative 1. Okay, that's where the substitution comes in. So this is the second step with the substitution. All right, so now I have an equation just in terms of x. So let's solve it for x. Well, how do we do this? So this goes back to chapter 2 again. I need to distribute the 5, right? So I have 3x. 5 times negative 3x is a minus 15x. And then 5 times negative 5 is minus 25. That equals negative 1. I can combine like terms. 3x minus 15x is a negative 12x. And then I need to add 25 to both sides. So I have negative 12x is equal to 24. And then finally, if I divide by negative 12, then I'm going to get x equals, and then positive 24 divided by negative 12 is a negative 2. So I have the x coordinate of my solution, right, of my point, which is the solution. Okay, so now I go to step 3. I take that solution for x and I plug it back into either of the equations. And actually, if you go back here, right, we can use either of these equations. I can plug my x into, or I can even plug it into this one, the one I manipulated. And that might be the easiest to plug into because it already is solved for y. So I have to plug it into one of those and solve it for y. Okay, so I'm just going to use that third one. That's the easiest one to plug into. So this is step 3. So I'm going to use the y equals negative 3x minus 5. Remember, this is just my second equation that I rearranged, right? I solved it for y. So I have y equals negative 3, x is now negative 2. Well, this is really, what, 6, right? Negative 3 times negative 2 is positive 6 minus 5. So y is going to equal 1. So x equals negative 2, y equals positive 1. So if I want my solution to be written as a point, as an ordered pair, then the solution would actually be negative 2, comma 1. And if you were to graph these two lines, that's where they would cross, right? Because that point is a solution to both equations, so it has to lie on both lines. So that's the point where those two lines would cross. Okay, here's another one. Let's say we're asked to solve 4x plus 2y equals 4, and then y equals 5 minus 2x. So that system of two linear equations. Okay, it looks like step 1 is done, right? Because the second equation is already solved in terms of y, right? The y is isolated, so that's good. So I can go right to step 2, right to the substitution step, and I go to the first equation, and where I have a y, I'm going to plug in that expression, 5 minus 2x. Okay, now I can solve this for x, right? So I would distribute the 2. So I have 4x plus 2 times 5 is what? 10. 2 times negative 2x is negative 4x. That equals 4. And then if I try to solve for x, look what happens here. 4x minus 4x is 0, right? Those happen to cancel. So I'm going to get something that says 10 is equal to 4. This is never true, right? This is always false. So what happens if you try to solve the system and you get something like this at the end, which is false, right? Clearly false. 10 does not equal 4. What this means, so this means there is no solution. So what does it mean about the two lines, those two original lines, if there's no solution? Well, those two lines must be parallel, right? They never cross. Remember, the solution is where the two lines would cross. So if there's no solution, right, no solution, it means the lines are parallel. So they never cross. And if you were to plot those two lines, if you were to graph them, you would see that they're parallel, right? They never ever cross. So that's kind of a special case, right? If you get something that's clearly false, right, that's never true, then there's no solution, and that's because the two lines are parallel. Okay, actually, let me do the other special case as well. Let's say this is our system of equations. Let's say we want to solve 2x minus 6y equals negative 12, and then x equals 3y minus 6. Okay, so again, the first step is done. Why? Because the second equation is already solved in terms of x. It's already isolated. I don't have to do any extra work. So the first step is done. Second step, I'm going to plug that expression, 3y minus 6, into the first equation. So where I have an x in the first equation, I'm going to plug in 3y minus 6. Right, so I have 2 times 3y minus 6 minus 6y equals negative 12. And now I'm going to try and solve this for y. So if I distribute the 2 here, I get 6y. 2 times negative 6 is minus 12. Minus 6y equals negative 12. Now notice what happens here, right? The 6y's cancel. And then I get negative 12 is equal to negative 12. Or what you want, if you want, you could do it this way too. You could add 12 to both sides. And you could say 0 is equal to 0. This is always true. So if you ever end up with something that says 0 equals 0 or negative 12 equals negative 12, right, something that's always true, what does this mean in terms of solutions? It means there's an infinite number of solutions. So infinite number of solutions. So what was true about those lines? They were both the same line. They were ultimately the same line. I'll say both equations represented the same line. They were really the same equation, right? In fact, if you simplify these, you can show that they're both exactly equal to the same equation. Okay? Actually, let's do that here. So, here, let me move this over a little bit. So I have 2x minus 6y equals negative 12. And then the other one was x equals 3y minus 6. Let me show you that they're both really exactly the same equation. Let's put them in y equals mx plus b form. So I'll say we're going to put these y equals mx plus b form, because then it's easy to see that they're exactly the same, okay? So what does that mean? It means solve the equation for y. So in this first case, I would need to subtract 2x. So I'm going to get negative 6y is equal to negative 2x minus 12. And then I'd have to divide by negative 6. So I'm going to get y equals, well, I can write this as negative 2x over negative 6 plus a negative 12 over negative 6. But that is really this. Negative 2 over negative 6 simplifies to 1/3 x. And negative 12 over negative 6 is positive 2. So I'm just rearranging that equation, but I put it in the y equals mx plus b form. So in this case, right, the slope is 1/3 and the b is 2. So let's do the same thing for this equation. So for this equation, I guess what I can do is I can add, I'm going to solve for y again, right? So I can add 6 to both sides. So I get x plus 6 equals 3y. And then divide by 3. But then, so this cancels. Now, let me just rearrange the sides that these expressions are on. So I'll write the y on the left-hand side. So I have y equals x plus 6 over 3. But this is the same as x over 3 plus 6 over 3. Right? I can put each term over 3. But x over 3, another way of writing that is 1/3 times x. And then 6 over 3 is the same as 2. So if you look at that, you can see that in reality, there's a little stray mark here. In reality, these equations are exactly the same, right? They represent exactly the same line. So that's why there was an infinite number of solutions. That's why when we tried to solve it, we got this 0 equals 0 or negative 12 equals negative 12, right? Either you can stop at either place there. If we get something that's always true, that means there's an infinite number of solutions, and that's because both equations really were the same line. Okay, what I want to do now is let's talk about the other technique that you can use to solve systems of two linear equations. So this is called elimination. Some people call it the addition method as well. And then later we'll do a bunch of applications, applied problems, using both of these techniques. Okay, so this is now the next section, 4.3. So solving using elimination. Okay, so this technique depends on the following property. So if A equals B, and so if I have an expression A equals an expression B, and I have another equation where it says expression C equals expression D, then you can add the left-hand side of the equations together and the right-hand side of the equations together, and they're equal. So then if I were to add the left-hand sides, right, A plus C, that's going to equal B plus D. Okay, so we can add the equations together. That's why sometimes this method is called the addition method. Okay, So let me give you the rules for doing this, and then we'll do a bunch of examples. Okay, to solve using elimination. First step, you want to write both equations in the standard form. So remember that's the form ax plus by is equal to c. So you want to write both equations in that form. You want the x's first, then the y's, and then on the other side put the constant. Okay, then you choose the variable you want to eliminate. It can either be x or y, doesn't matter. So choose the variable you want to eliminate. And then you may have to do a little bit of work to eliminate the variable. So you may have to multiply one or both of the equations by appropriate numbers so the coefficients of the variable to be eliminated are opposites. So the coefficients of the variable to be eliminated are opposites. Why do we want that? Because when we add those two, we want them to disappear. We want them to add to zero. So opposites will add to zero. Again, this will all make a lot more sense when we start doing examples. Let me just finish all the rules first, and then we'll do a bunch of examples. Okay, so once you do that, step 4 is now you simply add the equations. That will eliminate one of the variables, and you want to solve for the remaining variable. So say add the equations and solve for the remaining variable. And then finally, this is sort of the same as with the substitution method, this last step. Substitute the result from step 4. Back into either of the original equations to solve for the other variable. So plug it back in. It can be either of the original equations. And solve for the other variable. Okay, so let's do some examples using the elimination method. Okay, so first example, let's say I have, this is my system, say x minus y equals 10, and then x plus y equals negative 8. That's my system, right? And I want to solve it by using elimination. Okay, well, step 1 is done, right? Because these are both in the form ax plus by equals c, right? The x's are lined up, the y's are lined up, and the constants are lined up on the right-hand side. So that step is done. Then let's choose a variable to eliminate. We could eliminate either x or y. In this case, and you'll see why in a second, it's going to be easier to eliminate the y. And then it says step 3 was you may have to multiply one or both of the equations by appropriate numbers so that the coefficients of the variable to be eliminated are opposites. But if you look at the y here, see how this coefficient is a negative 1? I'll do it in red here. So this is a negative 1. And this one is a positive 1, right? If there's nothing there, you can think of it as a positive 1. So those are opposites, right? So step 3 is already done for us. We already have a negative 1y and a positive 1y. So now we can go right to step 4. We can add these equations together. And what happens if we add them together? Well, x plus x is 2x. And then what's negative y plus a positive y? That's 0, right? So the y is gone. We've eliminated the y. And that's got to equal, in the right-hand side, 10 plus negative 8 is positive 2. Okay, so I've eliminated y. Now I have an equation just in terms of x. I can solve this for x. I would just divide both sides by 2. So I have x is equal to 1. So I'm half done, right? And now I can do the last step, right? Step 5. Just plug that back into one of the original equations and solve for y. So maybe, I don't know, maybe the second equation was a little easier because it had a positive y. It was x plus y is equal to negative 8. So I'm going to use the second equation. So where I have an x, I plug in 1. And I'm going to solve that for y. So I need to subtract 1, subtract 1. So it looks like I'm going to get y is equal to negative 9. So that's my solution. X is equal to 1, y is equal to negative 9. If I want it as an ordered pair, as a point, then I'd write it as 1 comma negative 9 for the solution. And again, if you were to graph these two lines, right, the two original lines, that's where they would cross. They would cross at 1, negative 9. Okay, let's do some more examples that are a little more complicated where we have to do a little extra work, right, in order to eliminate a variable. So in this case, let's say I want to solve x plus 4y is equal to negative 3, and then x minus 7y is equal to 19. Okay, so I need to choose a variable to eliminate. Well, I could choose x or y, but the x we're going to find is much easier because see how right now I have my coefficient of this x is a 1, and this one in the second equation is also a 1. If I can make one of those a negative 1, then, and I just need to make one of them a negative 1, then I can add those two equations and get rid of the x's, right? I'll have opposite coefficients. Whereas if I wanted to eliminate the y's, here I have a plus 4 and a negative 7. I'd have to multiply both equations by a particular value to get an opposite coefficient there. In fact, I'd probably have to multiply the first equation by, say, 7. So then that will give me a 28y. And the second one by 4, so I get a negative 28y. So it's a little more work, right? You could do it, but I'd have to multiply both equations by something. In this case, if I want to eliminate the x's, I just need to multiply one of the equations by negative 1. So let's say we want to get rid of the x's. So what I'm going to do is I'm going to take that first equation and I'm going to multiply both sides by negative 1. Okay, and you have to be careful. Remember, both sides have to be multiplied by negative 1. So left-hand side by negative 1, and then right-hand side by negative 1. Well, if I distribute into negative 1 here, I'm going to get negative x. Negative 1 times 4y is negative 4y. And the right-hand side, negative 1 times negative 3 is a positive 3. Okay. Then I'm going to write down the second equation right underneath it. And now I have exactly what I want, right? The coefficient of the x terms are opposites, right? I have a negative 1 and a positive 1, right? By design, I did that on purpose so that these would be opposites. Now, when I add these two equations together, the x's are gone. So negative x plus x is 0. That's gone. Negative 4y minus 7y is negative 11y. And that's got to equal 3 plus 19, which is 22. But then to solve for y, I can divide by negative 11. So divide by negative 11. So y is going to be, well, positive 22 divided by negative 11 is a negative 2. Okay, so I'm half done, right? I have my y. Now let me go back and find x. So I'm just going to choose one of the equations to plug y into. Let me just use the original first equation. So I have, let's see, x plus 4y equals negative 3, right? That was the original first equation. But I know y is negative 2 now. So I have x plus 4 times negative 2 is equal to negative 3. So what's 4 times negative 2? That's negative 8. Right, so this is just minus 8 is equal to negative 3. And then I can add 8 to both sides. So I'm going to get x is equal to, I guess, positive 5. So my solution is going to be the ordered pair 5, comma, negative 2. Right, that will be the solution. X equals 5, y equals negative 2. Okay, here's another one. Let's say I want to solve (10x minus 3y is equal to 9, and then 3x minus 2y is equal to negative 5. Okay, in this case, there's no easy variable to eliminate. You could either eliminate the x or y. Let's say we choose to eliminate the y. Okay, so let's eliminate the y. So let's eliminate the y variable. So to do that, remember the coefficient of the y have to be opposite. But see how one is a negative 3 and one is a negative 2 right now? If I were to find the lowest common denominator of 3 and 2, so if I find, I'll write it this way, the lowest common multiple of 3 and 2, that's going to be 6, right? It's the smallest number that 3 and 2 go into evenly. So if I can make one of those coefficients a negative 6y and one of them a positive 6y, then when I add them, the y's will disappear. Right? Because I want those coefficients to be opposites. So if you think about this, let's make the top equation a positive 6y, okay? So how can I do that? Well, right now I have a negative 3. So how do I make that a positive 6? I need to multiply that by negative 2. But I can't just multiply that one term by negative 2. I need to multiply the entire equation by negative 2. So I'm going to multiply the first equation by negative 2. Just because I want that to end up being a positive 6y. And remember, don't forget both sides have to be multiplied by negative 2. So if I distribute this, right, I'm going to get negative 20x plus 6y, that's what I wanted, equals negative 18. Okay. Now, in the second equation, since I made this a positive 6y, I want the second equation to be a negative 6y. Well, right now I have a negative 2. So how do I make that a negative 6? Well, I can get a negative 6 if I multiply it by a positive 3, right? So I want to multiply the second equation, both sides, by a positive 3. Okay, so if I distribute this 3 here, I'm going to have 9x minus 6y. That's what I wanted, right? By design, I wanted negative 6y equals negative 15. Okay, so let me put these two equations together, right? The ones that I multiplied by so that I would end up with a 6y and a negative 6y. So let me bring these together. So I have negative 20x plus 6y equals negative 18, and then 9x minus 6y is negative 15. Okay, so this is great. So I did all the work now so that when I add these two together, when I add these equations together, what's going to happen to the y's? They're gone, right? I'm eliminating the y's. If I add negative 20x plus 9x, I'm going to get negative 11x. And then negative 18 plus a negative 15 is a negative 33. And then finally, if I divide both sides by negative 11, then I'm going to get x is equal to a positive 3. Excellent. So we're half done, right? X is positive 3. Great. Now I have to go and find y. Well, to find y, I can plug x equals 3 back into either of my original equations. In fact, you could plug it into the ones that you've manipulated too, right? It doesn't matter, any of these. You could either plug it into here, here, or either of your original equations. Okay, let's just, for no particular reason, let me just choose the second equation to plug into. So I'll use that second equation. So that's 3x, oops. So 3x minus 2y is equal to negative 5. And I want to plug in x equals 3, right? Where there's an x, I want to plug in 3. So I have 3 times 3 minus 2 times y is equal to negative 5. Well, 3 times 3 is 9 minus 2y equals negative 5. And then if I subtract 9 from both sides, I'm going to get negative 2y is equal to negative 14. And then finally, if I divide by negative 2, what's y going to be? Well, negative 14 divided by negative 2 is positive 7. So my solution is x equals 3, y equals negative 7. If I want to write it as a point, as an ordered pair, then I can just write it as 3, 7. So that would be my solution, 3, 7. X equals 3, y equals 7. Okay, what about those special cases where the lines happen to be parallel or they happen to be the same line? How does that, like, what happens when we try to solve it using elimination? So let me show you a couple of those cases because they could come up. So here's an example. Let's say I want to solve this system. 8x plus 2y is equal to 3. And then 4x plus y is equal to negative 9. Okay, so there's my system. let's say we want to eliminate, I don't know, let's say we want to eliminate the x's, okay? So if you look at the coefficient of the x right now, I have an 8 and a 4. Well, what's the lowest common denominator between 8 and 4? Or actually, I should really say the lowest common multiple. What's the lowest common multiple of 8 and 4? What's the smallest number that 8 and 4 will go into equally or evenly? It's 8, right? 8 goes into 8 once, 4 goes into 8 2 times. So 8 is the lowest common multiple of 8 and 4. So if I can make one of these a positive 8 and one of them a negative 8, then they're going to be opposites, and when I add it, I can get rid of the x's. Well, I already have a positive 8x for the first equation, so I should probably just leave the first equation alone. And to make this the coefficient of the x in the second equation a negative 8, I need to multiply 4 by what? I would need to multiply 4 by negative 2. So I'm going to multiply that second equation by negative 2. That's the first step, because I want to make sure I get a negative 8 in front of the x. And remember, both sides have to be multiplied by negative 2, so don't forget to multiply the negative 9 also by negative 2. So if I distribute my negative 2, I'm going to get negative 8x. That's what I wanted. Negative 2 times y is negative 2y, and that's equal to 18. Good. It doesn't matter what order you write the equations in, so I'm just going to write that first equation just underneath this one. So this is really the second equation, but it's been changed because I multiplied both sides by negative 2. So now I'm going to write the first equation just underneath this one. Okay, now I can add and get rid of the x's. But look what happens here. When I add negative 8x and 8x, that's gone, that's 0. But look what happens to the y's. Negative 2y plus 2y is also 0. And then 18 plus 3 is 21. So I'm getting 0 equals 21. This is always false. Right? That's never true. 0 is not equal to 21, so that's false. So what does that mean in terms of solutions? It means that, so if you get something like that, 0 equals some other number, right? Something other than 0. Then it means that there's no solution. But what does that mean in terms of the lines? Remember, it means that they don't cross, so they have to be parallel lines. So no solution, it's because they're parallel lines. Okay, and then the other special case would be this. So let's say this is your system that you want to solve. So 4x plus y equals negative 3, and then 8x plus 2y is equal to negative 6. Okay, choose a variable to eliminate. In this case, let's say we want to eliminate the y's in this case. Okay, so right now, my coefficient is a positive 2, and in this, of course, if there's nothing there, remember there's an implied 1 there, so it's a 1. And the lowest common multiple of 1 and 2 is just 2. So if I make one of them a positive 2 and one of them a negative 2, then when I add the equations, I can get rid of the y's, right? I want those coefficients to be opposites. Well, the second equation already has a positive 2 there, so I'll just leave that one alone. And I can fix the first equation. I can make that a negative 2y if I multiply the entire equation by negative 2. And again, don't forget to multiply the right-hand side. It's an easy thing to forget. Right? Both sides have to be multiplied by negative 2. You're not changing the equation, you're just rewriting it. Okay, so if I multiply by negative 2, well, negative 2 times 4x is negative 8x. Negative 2 times y is negative 2y, and that's equal to positive 6. And then the second equation, remember, it doesn't matter the order, so I guess I'm keeping the same order in this case. So second equation I'm just going to write underneath, so 8x plus 2y is equal to negative 6. Now look what happens in this case when I add the equations. So now I can add the equations, right? Negative 8x plus 8x, that's 0, so that's gone. But then negative 2y plus 2y, by design, we wanted to get rid of the y's, that's 0. So I'm getting 0 equals, and on the right-hand side, 6 plus a negative 6 is also 0. So I'm getting 0 equals 0, which is always true. So what does that mean in terms of solutions? It means you have an infinite number of solutions. And it means that those two lines were actually the same line. So I'll say both lines were the same. So they lie right on top of one another. So that means every point is going to be is a point where they intersect, right? In some sense. So if they lay right on top of one another, then every point is a solution. So there's an infinite number of solutions. Okay, so now I want to do some applications or some word problems that involve systems of equations. And in particular, we're always going to focus in this class on two equations by two unknowns. Okay, so here's the first application. Let's say you're asked to find two numbers and actually I'll give them names A and B. We could use X and Y, but let's call them A and B in this case, A and B, whose sum is 6 and whose difference is -4. Okay, so find two numbers, A and B, whose sum is 6 and whose difference is -4. So the first thing we need to do is we need to translate those that sentence into our two equations. Well, sum, remember, means to add, right? Remember, sum means add, addition. So if I have two numbers, A and B, and their sum is 6, then the first equation must be A plus B is equal to 6. And then difference is a subtraction, right? So if the difference is -4, then that means A minus B is equal to -4. Okay, so there's our system of two equations in terms of A and B. So now we want to solve this system, right? Solve it for A and solve it for B. We can use either substitution or elimination. Sometimes one method is easier than another. Sometimes it's sort of set up already for one method. In this case, if you look at this carefully, this is set up to just use elimination, right? Remember, elimination, I'll say use elimination. This is also called the addition method. Right, so that was the last thing that we talked about, or addition method. Why is this set up to use elimination? Because if you look at the b's here, the coefficient of this first b, is a +1, and the second b is a -1. So those coefficients are already opposites. If we just simply add these two equations together, so remember the next step would be to add these together. A plus A is going to give us 2A. But what's 1b minus 1b? That's 0, right? They add to 0. So we have eliminated the b's. And on the other side, we have 6 plus -4. That's equal to +2. So then if I divide both sides by 2, I'm going to have A is equal to 1. Great. So I'm half done. I have my A, right? I have the first number. It's got to be 1. And then to get the second number, remember you plug A back in. So plug 1 back into either of the two equations. Maybe we'll just use the first equation. So remember the first equation was A plus B is equal to 6. So I'll plug A in, 1 in for A. And I'm going to solve this for B. So how do I solve for B? Well, I need to subtract 1 from both sides. So it looks like B is equal to 5. So that's our solution. A is equal to 1 and B is equal to 5. Does it fit? Yeah, if I add 1 plus 5, that is equal to 6, right? So that checks. And then if I do the difference, 1 minus 5, well, that's equal to negative 4. So that checks. So that is the correct solution. A equals 1, B equals 5. Okay, here's another example. I'm just going to bring up a new page here. Let's say you're told that the attendance at a concert was 1,250 people. So 1,250. Admission was $20 for each adult. So admission was $20 for each adult. And $10 for each child. So and $10 for each child. You're also told that the total receipts, so the total amount of money that they collected, right, total receipts, were $22,500. And the question is, how many adults and how many children attended the concert? So how many adults and how many children attended the conference? Okay, so ultimately this problem is going to translate into two equations by two unknowns, right? So the first thing I want to do is I want to make up some names for the variables. We could use x and y, but since we're talking about adults and children, let's let A equal the number of adults. It'll be easy to remember there. So A is the number of adults. And then maybe, I don't know, C is the number of children. Okay, so given that information, right, given all this information, we want to come up with two linear equations involving A and C. Well, the first sentence says that the attendance at a concert was 1,250. There's 1,250 total people. So doesn't that imply that if I add the number of adults, A, plus the number of children, has to equal 1,250. Right? So the first equation just involves the total number of attendees at that conference. The number of adults plus number of children has to equal 1,250. Now the second equation is going to involve the total amount of money that was collected, right? So remember, if you look back here, it said admission was $20 for each adult and $10 for each child, and the total amount of money that they collected was $22,500. Okay, so let's think about this. Well, if each adult had to pay $20, then the total amount of money collected just from the adults must be 20 times the number of adults, right? If there were 10 adults, 20 times 10 would be $200 from the adults. If there are 100 adults, it'd be 20 times 100. In general, it's going to be 20 times A, right? Where A represents the number of adults. Plus, the total amount of money collected from the children must be the amount that each child paid, $10, times the number of children. So 10 times C must be the total amount of money collected from the children. And if I add those two together, 20A plus 10C, what does it have to give me? Well, it must be the total amount of money that was collected all together, which we know is $22,500, right? $22,500. Great. So that was the hard part, right? The hard part was setting up those two equations by two unknowns. Now I just need to solve this. So how do we solve it? Well, again, it looks like it's set up for elimination, but let's do substitution just for variety, just to remind you how to do substitution. So remember, substitution is to solve for one of the variables in one of the equations. So I'm just going to use substitution just for variety, just to remind you how to do it, even though I think elimination is probably easier, but we're going to do it using substitution. So let's say I want to isolate the A in the first equation. Okay, so let me write down the first equation. Again, I have A plus C is equal to 1250. So how do I solve this for A? Well, I need to subtract C from both sides, right? So A is going to be equal to minus C plus 1250. Okay, so now the substitution part comes in, right? I need to substitute in to the second equation where I have an A in that second equation. I have to plug in negative C plus 1250. So I go to that second equation, and where I have an A, I'm going to plug in negative C plus 1250. And by doing that, I have an equation just in terms of C now, and I can solve this for C. So how do we solve this for C? Well, first we have to distribute the 20. So 20 times negative C is negative 20C. Let's say 20 times 1250. I'll just do this quickly on a calculator. It's 25,000. Plus 10C is equal to 22,500. Okay, I can combine like terms, right? So negative 20C plus 10C is negative 10C. I still have a plus 25,000 is equal to 22,500. And now I can subtract 25,000 from both sides. So I have negative 10C equals, well, what's 22,500 minus 25,000? That's going to be negative 2,500. And then finally, to get C by itself, I'm just going to divide by negative 10, right? Divide by negative 10. So C is going to be, I guess, 250. So what this is saying is that 250 children attended this conference, right? We found C. Now we need to go back and find A. Well, how do I go back? Remember the rule for substitution? Well, I just plug it back into any of the equations, right? In fact, you could use one of the original equations, that one or that one, or you could use the one, the first equation that we rearranged. And this might be best because it already has the answer in terms of A, right? A equals something. So if I use that equation, right? So I'm going to use this one. A is equal to negative C plus 1250. So where I have a C, I'm going to plug in 250. So I have negative 250 plus 1250. And what's negative 250 plus 1,250? That's just 1,000, right? So I guess A is equal to 1,000. And we have our answer because remember, A represented the number of adults. So there were 1,000 adults that attended this conference. And C was the number of children. So there's 250 children. So that would be our answer. Okay, here's another one. Let's say you're told that Elizabeth has 28 coins. They are quarters and dimes. Their total is $5.65. Okay, and the question is, how many quarters and how many dimes does she have? So how many quarters and how many dimes? Does she have? All right, so again, to start off, let's create variable names. You could use X and Y, and sometimes it's easy to just use X and Y. But in this case, since we're talking about the number of quarters and number of dimes, let's use maybe Q and D. Okay, so let's say Q represents the number of quarters, and then D represents the number of dimes. All right, so now we need to come up with two linear equations that involve Q and D based on the information that we're given. So if you look at the first sentence, right, it says Elizabeth has 28 coins total. So that must mean that the number of quarters, Q, plus the number of dimes, that has to equal 28, right? The total number of coins is 28. And then the second piece of information we're given is that the total amount of money that she has in terms of quarters and dimes is what? $5.65, right? $5.65. So the way to write that is, well, think of it this way. How much money does she have just in terms of quarters? Well, we know that each quarter is worth 25 cents or $0.25. So if I multiply 0.25 times the number of quarters, that must give me the amount of money that she has in terms of just the quarters, right? So like if she had 8 quarters, then 0.25 times 8 would be $2. She'd have $2 in quarters. So whatever Q is, the total amount of money she has in quarters is going to be 0.25 times Q, right? Times the number of quarters. And then how do I figure out the amount of money that she has in terms of dimes? Well, it's going to be 0.10 times D, right? Because each dime is worth 10 cents or $0.10. And that's got to equal the total amount of money that she has, which is $5.65. Okay, so again, that was the hard part, right? The hard part was coming up with that system of two linear equations in terms of Q and D. Now that we have them, we can solve this system. What I would do first here is, just because we don't want to have to carry around these decimal values, maybe what you should do to get rid of the decimals is multiply both sides of that second equation by 100, and that will eliminate the decimals, right? So let me show you. So I'll multiply the left-hand side by 100. This is just the second equation, just so we don't have to worry about decimals. And then the right-hand side by 100. Okay, so if I distribute 100, well, 100 times 0.25q is 25q, right? I would just move the decimal 2 places to the right. And then 100 times 0.10d is the same as 10d. And then 100 times 5.65 is going to be 565. Okay, so that just cleans up everything. We don't have to worry about the decimals anymore. And now the first equation I'll just write down again. So I have q plus d is equal to 28. Okay, let's use, last one we did was substitution. Let's solve this by using elimination. Let's say I want to eliminate the d's. Okay, so right now I have a positive 10, right? Positive 10, and this is a positive 1. Well, I really want this term right here, the second term, to be a negative 10, right? If I can make that a negative 10, then the coefficients will be opposite, and I can just add them and get rid of the d's. Well, how do I make that a negative 10? I can multiply the entire second equation by negative 10. So I'm going to multiply that second equation by negative 10. And again, don't forget to do the right-hand side as well. So if I distribute that in, I'm going to get negative 10q minus 10d. That's equal to negative 280. And the first equation is fine, right? I can just write that down again. In fact, it doesn't matter what order I write the equation, so I'll just write it underneath. 25q plus 10d is equal to 565. So that was fine. Okay. Now we can add them, right? The d's are going to disappear. We're going to eliminate. We're using elimination. We're going to eliminate the d. So the d's are gone, right? Negative 10d plus 10d is 0, so that's gone. If I add negative 10q plus 25q, that gives me 15q. And then negative 280 plus 565 happens to be 285. So then to get q, I'll divide both sides by 15. And that's going to give me q is equal to 19. So what does that tell me? It tells me I have 19 quarters, right? Remember, q represented the number of quarters. Now I have to go back and figure out the number of dimes. Well, I can plug this q equals 19 back into any of the equations I want, but the easiest equation to plug back into is going to be the one that says q plus d is equal to 28. Right? You could use both of either one, but this one's much easier to plug into. So where I have a q, I'm going to plug in 19, and I'm going to solve this for d. Okay, so how do I get d by itself? Well, I need to subtract 19 from both sides. So d equals, and then 28 minus 19 is 9. So in this case, it looks like Elizabeth has 19 quarters, right? Because remember, q represents the number of quarters, so she has 19 quarters and 9 dimes. And you can check to make sure this makes sense, right? If I add 19 plus 9, I get 28. That's good because she has 28 coins total. And then if you were to multiply 19 times 0.25 and then 9 times 0.1 and you add them together, you better get 5.65, right? You better get $5.65. Okay, so that works out. And I want to do one more application. So for this last application, it's going to be a little bit of physics. You guys know I like physics, so, but not too much, just a little bit of physics. So in this one, it says a crew team rows in a river with a current. when the team rows with the current, so if they're going in the same direction of the current, so when the team rows with the current, the boat travels 14 miles in 2 hours. So the boat travels 14 miles in 2 hours. And then if they row against the current, so against the current, so they're fighting the current now, they're going to go slower, right, if they're fighting against the current. So against the current, the team rows 6 miles in the same amount of time. So in the 2 hours, they row 6 miles. So the team rows only 6 miles now in the same 2 hours. So I'll say in the same amount of time. And the question is, at what speed does the team row in still water? Like, what's their speed had there not been any current at all? So the question is, at what speed does the team row in still water? And I guess the other question we could ask, because you're going to need to figure it out anyways, is what is the speed of the current, right, of that river? So what is the speed of the current? Okay. So it sounds like a complicated problem, but it's not as bad as you guys think. So there's one thing that we need from physics first. We need the fact that the distance, so we need a formula from physics. The fact that the distance traveled, so distance, is equal to the speed times the time. So think of this like if you're traveling on, the Mass Pike, and you travel at, let's say your speed is 70 miles per hour, and you travel for 2 hours, then the distance is going to be 70 times 2, right? 140 miles. So in general, distance is speed times time. Okay, now remember, what are we looking for here? We're looking for the speed of the team and how fast they row in still water, so the speed of the boat in still water, and then the speed of the current. Okay, so give those names. Again, you could use X and Y, but let's say S is the speed of the boat in still water. And then maybe C is the speed of the current. Okay, so we're going to use this idea that the distance let me write that better. So distance is equal to speed times time. So let's see if we can come up with the two equations that we need. Well, the first equation is going to involve rowing with the current. So I'll say with the current. That'll be our first equation. So what is the distance traveled? Well, they tell us that the boat travels 14 miles in 2 hours if we're rowing with the current. So the distance is going to be 14 miles Okay. Now here's the tricky part, the speed. Well, if you're rowing with the current and your speed of the boat in still water is S and the speed of the current is C, it turns out that you need to add those two together, right? Because if you're rowing with the current, it's going to appear to someone just standing on the shore as if you're rowing even faster, and those velocities add. So if I'm rowing with the current, my speed is actually going to be the speed that I would row with no current in still water plus the speed of the current. And I have to multiply that by the time, but what's the time in this case? Well, they said it was 2, right? 2 hours. So that's my first equation. Rowing with the current. My distance is 14 miles. My speed is going to be the speed of still water plus the speed of the current because I'm rowing with it, so I'm going even faster. And I have to multiply that by 2. Then the other equation is going to be when I row against the current. Okay, so how far do we go? Well, it says 6 miles, so 6. What do you guys think the speed is going to be if you're rowing against the current? Well, it'll be the speed that you would row in still water, but now you're fighting the current, so you have to subtract the speed of the current, right? So it's going to be actually S minus C. And then times the time it takes, well, they again tell us it's the same amount of time, so it's 2 again. Okay, so that's the hard part, and this is definitely one of the harder questions. But those are the 2 equations, right? 2 equations by 2 unknowns that we want to solve. Okay, so let's look at this. What I would do is I would distribute the 2. So let me write this. I'm going to move the right hand side to the left hand side and put the 2 in front, just so it's easier. This is the way we typically see it, but right, it's the same thing. And then for the second one, I'll do the same thing. So 2 times S minus C is equal to 6. And now we're going to distribute in the 2. So for the first equation, right, I'm going to get 2S plus 2 times C is 2C. That's equal to 14. In the second equation, I'm going to get 2S minus 2C. That's equal to 6. Okay, now I have a choice. I can either use substitution or elimination. But if you look at this, can you guys see how it's set up to just use elimination? Right? This, in fact, we don't have to really do anything else, right? The C's, the coefficients are positive 2 and negative 2. So if I add the equations together right now, I'm going to eliminate the C. So it's really already set up for elimination. So I'm just going to add these together. So I'm going to get 4S is equal to 20. And now if I divide by 4, I'm going to get S is equal to 5, right? Miles per hour. So remember, S stood for the speed of the boat in still water. So it looks like the speed of the boat, if there were no current, they could row at 5 miles per hour. Now, we also want to figure out the speed of the current. So how do I figure out the speed of the current, which is C? Well, I can just plug this back in, right? And I can use either of these equations, right? Just plug back into one of these equations. Let me just choose the top one. So I have 2S plus 2C is equal to 14. And I know that S is 5. So 2 times 5 is 10, right? Plus 2C is 14. I'll subtract 10 from both sides. So 2C is equal to 4, and then divide by 2. So it looks like C is equal to 2, and it has units of miles per hour since it's the speed. So what we found here is that the speed of the boat in still water is 5 miles per hour, and the speed of the current of that river was 2 miles per hour. And it makes sense. So remember, if we add these together, if we add 5 plus 2, that's 7 miles per hour. That's the speed that they appear to be going if they're traveling with the current. And if you multiply 7 miles per hour times 2 hours, that gives us the 14 miles here, so that checks. And then if they're rowing against the current, then it appears from the shore that they're rowing at 5 minus 2 or 3 miles per hour. And if I multiply 3 times 2 hours, I get my 6 miles. So both of these check. So those are the correct answers. So the speed of the boat in still water is 5 miles per hour, and the speed of the current is 2 miles per hour. Okay, so that's all I want to do for applications. I basically covered the types of problems that you will see in MyOpen Math. There'll be a few problems that you have to do, some applications, and those are sort of the types of problems that you'll see. Great. I will see you guys soon, or at least talk to you soon through these video lectures. And our next lecture will be to review the practice for chapter 4. So I will post a practice for chapter 4, and I will do a video lecture going over the entire practice sheet. So make sure you have all that. And then we can start our last chapter of the book, which is chapter 5, which is on exponents and polynomials. And I think actually that you're going to find that chapter 5 is a little bit easier. So like chapters 1 and 2 were a little bit easier. 1 was mostly review of pre-algebra, right? Then chapters 3 and 4 are kind of the hardest. At least most students find chapters 3 and 4 to be the hardest. And then chapter 5 gets a little bit easier. It's more like manipulating equations, so it's more like just remembering a bunch of rules for exponents. But I think you guys will find it to be a little easier. All right, great.